In this video, we will look into stratified random sampling. So this is one of the sampling techniques, which are random sampling techniques. We have already seen in the previous videos what is a random sampling and what is a non-random sampling. And here we are going more in detail into random sampling, and stratified random sampling is part of the random sampling technique. Before we go into the video, if you have not subscribed to the channel, can I ask you to subscribe, because that will help you to receive all our videos. We upload educational videos both on maths and statistics, and we will be able to reach you from time to time. Thank you for watching. Let's proceed, jump into the subject. So in stratified random sampling, constantly you will hear the words homogeneous and heterogeneous. And in statistics, you will constantly again hear these words homogeneous and heterogeneous, because this is a way in which the population is normally classified. So let's first understand what's homogeneous and what's heterogeneous. So then whenever you come across this term, it will help you to understand it better. Right, I have for you two solutions here. The first mixture is a mixture of water and sand, and that you can see here. And the second one is a mixture of sugar and water. You can see it here. So we all know by simple logic and by common sense that when sugar and water are mixed nicely together, in course of time they would mix well, and you would have a evenly mixed solution. Whereas if you mix sand and water, whatever you do, how much of stirring you do, you would still find after some time the sand particles come down and settle and the water separate on the top. All right, so we're not doing any physics here, but this is just for you to understand what would a heterogeneous mixture would look like and what a homogeneous mixture would look like. So applying this into statistics sampling into a population, a heterogeneous population is a population which is divided into many groups. Here you can see there's a water, there's sand, they're divided. And if you want to find anything, you need to take samples of both the sand and the water from different parts. Whereas here in the homogeneous mixture, they're evenly selected, mixed. So you take the sample from any part, they would still all represent the entire population. So let's dive in. Let's look into this population, which is subdivided, which is heterogeneous, and it's subdivided. You can see you have the blue, the green, and the red groups. Right? So this population, we can say, is subdivided into subgroups. So what I'm going to do is, in stratified random sampling, we're going to collect all the red, all the blue, all the green, and put them together. So we call each of them as strata. So we have three stratas here. One is blue, second is the red, third is the green. So after classifying them, subdividing them into subgroups or strata, then you also see that you have more of the blue, less of the red, and very few of the green. Now by simple logic, if I'm going to take more samples from here, then this green does not properly represent my population, because you have more blue than green. Okay, so applying this method of logic, what we would do is we would take more samples from the first strata, which is the blue, fewer samples from the red, and a very few samples from green, and we can use percentage method to find it. So we will have more samples from blue, fewer from red, and few from green. All right, so I hope this has given you a basic introduction and an understanding to what is a strata and how to choose samples from this strata. Let's look at a mathematical method of uh, applying, and finding these samples. So here I have for you an example. I have three categories of people. The first is lower income class, which is 39%. So yeah, so this is the first category, and you have a total population of 500 people. Okay, and you have the second category, which is 38%, which is the middle income class. Then you have the category 3, which is the upper income class. So we know there are 500 people in all, and you're expected to find or pick up 68 random samples. Now, would you be taking all your 68 random samples from the lower income group only, ignoring the other two category? You wouldn't do that. If you do that, your sample is not properly represented. And if I'm going to take all the 68 from category 3, then again, your sample does not properly represent the entire population. So let's see how you can use percentage technique on selecting samples from this uh, population of 500, which is heterogeneous. Okay. So I have here put the three categories. These are our stratum, and each of them within the strata is a homogeneous group. It's a heterogeneous here, but we have classified them into homogeneous groups, three homogeneous groups. The first is lower income class, second is middle income class, third is the upper income class. And we know from our given information that 39% of the people or the population are from lower income class, 38% are from middle income class, and 23% are from upper income class. So I will apply this percentage onto the population, which is 500. So if I say 39 over 100 into 500, this will give me the number 195, which identifies there are 195 people in the population who belong to the lower income class. Let me repeat it for you. In the lower income class, which is our category 1, you have 195 people. Okay, so out of 500, 195 are lower income class. Same way you can find 190 are from the middle class, 115 are from upper class. All right, so now that we have our number of people who fall in each category, then I'm going to use this number to find my samples. How would I do that? Again, it's a percentage method. So I'm going to multiply this 195 into 68 over 500. So 68 is the number of samples that we need, and you have the total population of 500, and I'm going to multiply it with this 195. So your 195 divided by 500 can be a weight of proportion, the weight that we are adding to this population. So times 68 would give you 26.5. You can call that as 26. So you would take 26 samples from the first group of people. Then similarly in the second group also, because they're very close, you would still end up having 26 from the second group of people. And the third, which is 115, you would end up getting 16 numbers. So we can see very clearly that to choose the sample, you are going to use 26 people from the first group, 26 people from the second group, and 16 from the third group. So this method of subdividing the population into strata and making them homogeneous and then adding a weighted average to take The number of samples that we require from each of them is called stratified random sampling. Hope this video helped you. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.